Hello, I'm Kelly Washington Adams, and this is my video reflection on algebraic thinking and reasoning. I will be doing a reflection from the article Algebraic Thinking in the Early Grades What is It by Carolyn Carrion. Also, the video reflection of KCM Routines for Reasoning, Fostering the Mathematical Practice in All Students. This is done by KCM Director D. Crescentelli. And also, I'll be doing a reflection combined with Just What is Algebraic Thinking by Shelley Kriegler. With the key concepts, as I reflect on the readings on the video, the readings and the video, my understanding of algebraic thinking has really expanded. One of the biggest takeaways is that algebra is not something that suddenly begins in middle school. Instead, it develops over time, starting in the early grades through patterns, relationship, reasoning, and problem solving. All three sources emphasize that algebraic thinking is a process that develops over time, and that's beginning in the elementary grades through patterns, relationships, reasoning, and real world connections. The video especially reinforced that students are already doing algebra when they notice patterns or explain how numbers change, even if they are not using variables yet. This as I reflect on the articles by Kriegler and Carrion, along with the video on reasoning or routines. Where Kriegler explains that algebraic thinking is built on two key components: mathematical thinking tools and fundamental algebraic ideas. The thinking tools include problem solving, representation, and quantitative reasoning. These are the skills that help students make sense of mathematics. At the same time, students develop algebraic ideas by understanding algebra as generalized arithmetic, as a language, and as a tool for modeling real world situations. What stood out to me is that these two components must work together. Students cannot truly understand algebra if they are only memorizing procedures without developing reasoning skills. Carrion takes this a step further by explaining the shift from arithmetic thinking to algebraic thinking. In arithmetic, students often focus on getting the answer, but in algebra, the focus shifts to understanding relationships between quantities, representing those relationships and thinking about structure and meaning. For examples, students must begin to see the equal sign not just as the answer comes next, but as a symbol that represents a relationship. They also need to become comfortable working with unknowns and expressions, even when there is not a single numerical answer. The video reinforced these ideas by emphasizing the importance of mathematical practices and reasoning routines. It highlighted practices like making sense of problems, reasoning abstractly and quantitatively, and looking for structure in repeated reasoning. What I found powerful is that these practices show us how to bring algebraic thinking into the classroom every day. Through routines like think time, partner discussion, and whole group sharing, students are given opportunities to explain their thinking, make connections, and deepen their understanding. How algebraic thinking develops is through starting with arithmetic thinking. Of course, it's focused on computation and finding answers. Then goes to notice patterns, the spot and describe patterns, uses tables and drawings, uses tables and drawings to represent relationship using models, understand the equal sign, see that equal sign as a relationship. Algebraic thinking focus on finding and explaining relationships. The mathematical thinking skills are exploring patterns, analyzing relationships, and explaining reasoning. And why algebraic thinking is important in education: it helps build problem solving skills, it enhances logical reasoning, it prepares for advanced math, it supports STEM learning, develops abstract thinking, and is useful in everyday life. How all this is related to my teaching. As a fourth grade math teacher, I see these ideas play out in my classroom all the time. My students are often comfortable with computation, but they sometimes struggle to explain their thinking or recognize patterns. For example, during input output activities or number patterns, some students want to jump straight to the answer instead of identifying the rule. This reflection reminded me of those moments that are critical. When I ask questions like, "What do you notice?" or "How do you know?" I am helping my students move from simply doing math to actually thinking mathematically. So, overall, all three sources really help me see that algebraic thinking is a process. It develops over time, and it is something we should be building every day, not waiting to teach later in high school or middle school. And it's important because it helps students become better problem solvers, better thinkers, and more confident in math. As teachers, we just have to be intentional about giving students those opportunities to explain, opportunities to explore, and really make sense of what they're doing. And that's something I definitely want to keep growing in my own classroom. So, thank you for your time of listening to me do my reflection. Have a great day.